So we have a piece of cardboard 30 centimeters long and 25 centimeters wide. We're making a box with no lid, so this is very similar to the problem that we were working on before. We can draw a picture of this, and again, that's going to be a really helpful strategy when solving these problems. Draw a picture of this. We have 30 centimeters here, 25 centimeters here, and we're going to make a box by cutting out squares out of the corners. So these black lines will be our dimensions inside the box. Exactly what we did, but with different, nicer numbers as far as measurements go. Part A, well, I'm going to just label one more thing on here. The height of this box will be x, because those are the side lengths cut from the corners. So write a polynomial function to represent the volume. So volume equals length times width times height. Our length was 30, but you'd have to subtract 2 x's. Our width was 25, but now you'd have to subtract 2 x's. And the height of our box will be x. When we graph this function, again, first of all, we want to be able to graph this by hand. And the way that we've written it, we have all of our x-intercepts. So we know that there is an x-intercept at 0. There's going to be one at 12.5 and one at 15. If we think about our x's, we have a negative x in our first bracket, a negative x in our second bracket, an x in our third bracket, and that makes an x cubed in total. So an x cubed graph acts like a line as far as end behavior goes. And so we can get an idea of what the graph looks like. Now, if this was what we were graphing without a situation, our domain would be everything. But because we've got a real life situation that we're dealing with, our domain here goes from 0 to 12.5. So it only makes sense when x is between 0 and 12.5. 0 doesn't really make sense. Neither does 12.5, because either way you wouldn't be able to make a box. But any other little bit that you cut out would make a box. So here's our graph. Now we want to put this into our graphing calculator so that we can find our maximum. Again, it's important to be able to get our equation by hand so that when we go to graph it, so we'll go to our y equals, we'll type in 30 minus 2x, 25 minus 2x times x. When we go to graph this, we want to make sure that our window is set up. I want to go from 0 to 12.5. So maybe I'll start at -2 and go up to 15 just so I'm a little bit more on each side. I also like to start in the negatives so that I can see part of my y-axis later on. Same thing for my y-min. Now to figure out how high I need to go on my y-min, before I could just guess. So let's say I want to go up to 100, and you could graph and find out. Obviously that wasn't enough. Should come back down. There it is, going through 12.5. We can go second graph to our table and get a sense how high these numbers are going. So it looks like at 5 it's 1500. I know that the maximum has to be somewhere between 0 and 12.5. So at 1500 at 5, now I can go back to my window. I'm not going to put 1500 because it might still go higher than that. Maybe I'll go up to 2000. And now I should be able to see my maximum in that graph. And sure enough, there it is. So now that we have that, we can go second, calculate. Number 4 is a maximum. Again, it says go to the left, go to the right as a shortcut. If you don't want to use your arrow keys over, you can click a value that you know for sure is to the left. So I'm going to put 2, that's to the left of it. Looks like 8 is to the right of it. And it doesn't matter how wide or how narrow that is, as long as your maximum is in between those two values. Time to guess. Oh, and there it is, 4.53. Did it ask what to the nearest tenth? So x should be approximately 4.5 centimeters. And then you could calculate everything else as far as the dimensions are from that. So our dimensions would be 21, because that would be 30 minus 2 times 4.5 by 25 minus 9, 16 by 4.5. These are all centimeters. Did it ask for the maximum volume? So we need to say that our max volume is, go back to our calculator, 1512. Does it say to the nearest cubic centimeter? 1512 centimeters cubed. So more cardboard box questions. Questions 3 to 6 and 9 and 10.